In this video, we are going to talk about expectation. So this is going to be what would happen over the long haul if we were to repeat an experiment over and over and over and over again. What would be the expected outcome? So that's what we're looking at here. So it turns out that expectation is really just a big sum of a whole bunch of things. We're going to take the probability of an event happening times its outcome plus the probability of it happening times its outcome. And we're just going to add all of those things together. So let's look at an example of how this is going to work. One of the wagers in roulette is to place a bet on one of the numbers from 0 to 36 or on 00. That number comes up, the player wins 35 times the amount of bet and keeps the original bet. Suppose a player bets $1 on a number. We want to know what's the player's expectation. So let's look at the total number of numbers here. Because we've got to figure out a probability. So I need to know how many numbers are from 0 to 36 or 00. So I've got one here, and if I were to count all the numbers from 0 to 36, I'm actually going to have 37 numbers there. So I have a total of 38 numbers. Now, if they guess the correct number, then they're going to win, right? So my expectation, if they guess the correct number, they're going to win. Well, what's the probability of guessing correctly? That probability is going to be 1 out of 38. There's one way they can guess correctly out of the 38 numbers there. And we're going to multiply it by the amount that they win. Now, since they're only betting $1, they're going to win, if they guess correctly, they're going to win 35 times that dollar. So it's going to be 35. And then we're going to add the probability of not guessing correctly times the amount lost. So if the probability of winning is 1 out of 38, the probability of losing would be 37 out of 38. And they're going to lose $1 in this case. And to show a loss, we're going to make that a negative. And then we're just going to type that in our calculator. And I'm getting negative 0.05 for that. And I rounded this to two decimal places since we're talking about money. So what does this mean? This means on average, the player is going to lose about 5 cents every time a bet's made. Essentially. So if they were to repeat this experiment over and over and over and over again, and then to look at that average over the long run, that's what this is trying to find that average over the long haul there. And it would be approximately a 5 cent loss average. Now, if they were to do this hundreds and hundreds of times, we would expect them to win some, but we would also expect them to lose a lot too. It's always going to be a loss in a case like this. Let's look at insurance. Life insurance policies are another example where we can look at expectation. Let's look at an example. According to mortality tables published in the National Vital Statistics Report, the probability that a 21-year-old will die within 1 year is approximately 0.000962. Suppose that the premium for a 1 year $25,000 life insurance policy for a 21-year-old is $32. What's the insurance company's expectation for this policy? So we're looking at it in terms of the insurance company. So are they expecting a loss or a gain in this case? And we would expect the insurance company to have a gain over the long haul here. If they were to insure thousands and thousands and millions or even of 21-year-olds, what would happen over the long haul for that particular year? So expectation is going to be, we're going to look at, in this case, the probability that a 21-year-old will die, and then the amount paid out, plus the probability that the 21-year-old will not die that year, times the amount. So the probability that a 20-year-old is not going to live through that year is 0.000962. If that were to happen, then they're going to pay out some money. Now, they've already got the 32. They're going to pay out the 25. So the payout amount is going to be the 32 that they gain minus the 25,000 that they lose. 32 minus 25,000 is going to be a negative number, negative 24,968. So now let's look at that other half. Because one of two things is going to happen. They're either going to make it through the year or they're not going to make it through the year. So that's why we've got two things that we're adding together in this group. So what's the probability that a 21-year-old will make it through that year? It's the complement of this. So it's going to be 1 minus 0.000962. When I did that, I got 0.999038. And then the amount that they received $32. So when I compute this, that's going to be my expectation for that insurance company. And we could type this in the Desmos. I'm using an off-screen calculator. And I got $7.95. So what does this mean? This means that on average, the company is earning $7.95 for each of these policies sold. So that's how we do expectation.